In this video, we will practice finding limits by factoring, rationalizing, and a variety of other algebraic strategies. So on problem number 52, we should probably go ahead and rewrite this problem in factored form before we even do anything else. So this limit will be the same as the limit as x approaches 2 of, now I'm going to factor the numerator here. X squared will only factor as x times x. 8 will factor as 1 times 8, but also 2 times 4. And to get a middle of positive 2, we're going to need a negative 2 and a positive 4. So we factored the numerator. Let's also factor the denominator. X squared, again, factors as x times x. 2 will factor as 2 times 1. To get a middle of negative 1, we need a negative 2 and a positive 1. Notice that we have this common factor in the numerator and the denominator. This is something that happens very often. So we can cancel that out without changing the limit. So this will equal the limit as x approaches 2 of x plus 4 over x plus 1. Our goal is always to try to get to a point where we can do direct substitution. So direct substitution will work right now. I'm going to go ahead and substitute 2 for all of the x's. So this will be 2 plus 4 and 2 plus 1. So the limit is going to be 6 over 3, which is 2. By the way, notice how I kept writing this expression right here, the limit as x approaches 2. I kept copying that over and over again, right up until I did the direct substitution. That's when I dropped that limit expression. So make sure you do the same. Until you do the direct substitution, you have to keep writing limit over and over again. By the way, I had mentioned how we love to do direct substitution. So maybe just once I should point out why direct substitution won't work in this form. So imagine that I tried to do direct substitution right now. And so I'm going to substitute 3 for all the x's. So this would become the square root of 3 plus 1 minus 2 over 3 minus 3. So that is going to give us the square root of 4 minus 2 over 0. Already that's somewhat of a problem, but it's only really a problem if we get a 0 in the numerator and the denominator. But oh look, the square root of 4 is 2, so we're going to have 2 minus 2 over 0, so that is 0 over 0. This is called the indeterminate form. And when this shows up, it really tells you nothing about the limit of the original problem. So that's why we have to rewrite this problem in another form where direct substitution will not give us 0 over 0. When you see the square root in a problem, that's a big hint that you are probably going to use the technique of multiplying by the conjugate. Remember, if I have an expression like a plus b, the conjugate of this would be a minus b. And this is useful because when you multiply two conjugates together, you're always going to end up with a squared minus b squared. Just right away, the middle term cancels out. So we can use this strategy to get rid of the square root in the numerator and kind of just rearrange the entire problem. So the conjugate of the numerator would be the square root of x plus 1 plus 2. So of course we have to multiply by the same thing in the denominator so that we're not really changing the value of the problem. So in the denominator, I will also multiply by the square root of 1 plus 2. So let's see what happens. So this will equal the limit as x approaches 3 of. Okay, so we're looking for a squared minus b squared. And this is a, and this is b right here. So a squared, if you take the square root of x plus 1 and you square it, you're just going to get x plus 1. Squaring this makes the radical go away. So that's my a squared. And then I'm going to have minus b squared. Well, b is 2, so b squared would be 4. So when we use this technique, we automatically, basically the square root goes away, and then we wind up squaring this one. So I have x plus 1 minus 4 in the numerator. In the denominator, I will leave this as x minus 3 times the square root of x plus 1 plus 2. I'm just going to leave that like it is for now. So let's combine like terms and see if we can get something where we can use direct substitution without getting 0 over 0, which is the big problem. Well, positive 1 minus 4, that's negative 3. So check it out. We get x minus 3. All right, does that look familiar? Because in the denominator, we also have x minus 3. And then the rest of it, square root of x plus 1 plus 2. But of course, this is the key right here, the fact that we have an x minus 3 in the numerator and denominator. For these limit problems, you should always be watching out for something to cancel like this, because that's really the way that we wind up avoiding the whole 0 over 0 case. So this will be the same as the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. Let's try a direct substitution now and see if it works out okay. So I'm going to do my direct substitution over here. So notice right now, because I'm plugging in the 3, this is when I get to stop writing the limit as x approaches 3. So I'm going to have 1 over, maybe I'm going to write direct sub, just so the College Board can follow my work. I'm always pretending that I'm taking the AP exam. So right now I'm going to have 1 over the square root of 3 plus 1 plus 2. And this is going to be 1 over the square root of 4 plus 2. And that's going to be 1 over 2 plus 2, which is 1/4. So that is the limit. So just mentally imagine that you did direct substitution on number 56. So you should always sort of check this, because every now and then you'll run into a problem where direct substitution will actually work. And if you go through all of these crazy shenanigans of rationalizing, and you might do a half a page of work only to realize you could have done direct substitution and save yourself a ton of time. So at least mentally, imagine plugging in 0 right here. Well, that's just going to leave radical 2 minus radical 2. So that's going to be 0 in the numerator. If I also plug in 0 for this x right here, of course the denominator is 0, and there is the indeterminate form, which tells us nothing. So that's why we have to use other strategies. Because we see the radicals, the square root symbols in here, our best bet is to try multiplying by the conjugate. That will usually be the way to go. So the conjugate of the numerator is the square root of 2 plus x plus the square root of 2. So it's the same thing, except instead of a minus, I put a plus. I will have to multiply by the same exact thing in the denominator, so I'm not really changing the value of the problem. Okay, and the benefit of multiplying by the conjugate is that we're going to end up with a squared minus b squared, where this is a and this is b. So I'm going to have the limit as x approaches 0. Now if I do a squared, if you square a radical, the radical goes away. So I'm just going to end up with 2 plus x. So I've got a squared minus b squared. So there's my a squared. Here's minus b squared. Again, the radical goes away, and I'm going to end up with 2. So that is the result of multiplying by the conjugate. I'm going to leave the denominator the same for now. So I'm going to have the square root of 2 plus x plus radical 2. Let's go ahead and combine like terms and see if we end up with something that will allow us to do direct substitution. So I'm going to have the limit as x approaches 0. Well, in the numerator we see the 2 and then the minus 2. Those cancel each other out and we just have x. The denominator we leave the same. That's radical 2. Notice that we have a common factor in the numerator and the denominator. These x's will cancel out without changing the value of the limit. So this equals the limit as x approaches 0 of 1 over the square root of 2 plus x plus the square root of 2. And this is something where we can use direct substitution to evaluate. So let's go ahead and do direct substitution. In fact, I'm going to go ahead and write direct sub so everyone can follow what I'm doing. And as I substitute 0 for x, this is when I get to stop writing the limit as x approaches 0 over and over again. So I'm going to now have 1 over, well, if x is 0, I'm just not going to write that. So I'm just going to have the square root of 2 plus the square root of 2. Well, there's 2 of these, so that's the same thing as 2 square root 2. And actually, I would encourage you just to stop right there and leave your answer in this form. This is perfectly acceptable. We could rationalize the denominator and write this in another form. But this is perfectly fine for the College Board, and it's perfectly acceptable for me. Just in case you run into this as a multiple choice question, I do want to show you one time how to rationalize the denominator and write this in another form. So if I wanted to rationalize this, I would simply multiply the numerator and denominator by radical 2. So watch what happens. Well, in the numerator, now I just have the radical 2. In the denominator, I have this 2 out in the front. But also, when you multiply radical 2 times radical 2, the radicals go away and you just have 2. So this would be the same thing as radical 2 over 4. So this would be an equivalent form of your limit. And again, the only point of this is in case it's a multiple choice questions, if you have a multiple choice question and the original form is not one of the choices, then you would go ahead and rationalize the denominator, and then this form would be among your answers. On number 58, we will have to use a different strategy. I don't see any square roots or anything, so multiplying by the conjugate will not help us. What can we do? So there are 2 little algebraic shortcuts that I want you to memorize and be familiar with. One of them is if I have a plus b over c. This is equivalent to having a over c plus b over c. So if you have a sum and in the denominator you have a monomial, you can split this up into 2 separate fractions. So that's something that I can do right now. As I look at this problem, I can rewrite this as the limit as x approaches 0 of, and I'm going to take my first fraction of 1 over x plus 4. And I'm going to put that over x. And see that minus sign right there? So I'm just going to go ahead and write, put a minus sign right here in the middle. And then I have 1 over 4, and that is also over x. Okay? Now, here's the other algebraic shortcut that I want you to be comfortable with. If I have a fraction, and then I want to divide that by an additional number. So if I have the fraction a over b, and then I want to divide that by c. What happens is the c is just going to end up multiplying in the denominator. So this is going to become a over b times c. So if you divide a fraction by another number, just multiply that number by the denominator and you're good. And that's why I really would have skipped this entire step that I just wrote. Using the shortcut that I just mentioned, as I divide, this x is going to end up in the denominator, and this x is going to end up in this denominator. So I encourage you to go straight to the following steps. So we have the limit as x approaches 0 of, and really right away we can put x plus 4, and because we're dividing by x, we'll just put the x in the denominator. So we have this. So the strategy that we're going to use is we're going to get like denominators and combine these into one big fraction, and then see what happens. So like denominators, I see that the left expression has a denominator of x plus 4. So I'm going to need an x plus 4 in the other denominator. So I'm going to go ahead and put an x plus 4 right here. So of course, in order to do that, I need to put x plus 4 in the numerator as well. That way I'm not really changing the value of the problem. So these denominators are looking pretty similar. They both have x, they both have x plus 4. However, the denominator on the right has a 4 in front. The denominator on the left doesn't. So I'm going to go ahead and put a 4 here. And again, that will only be allowed if I also multiply the numerator by 4. Now we have like denominators, so we can go ahead and combine these into one big fraction. So this equals the limit as x approaches 0. All right, my common denominator is 4x times x plus 4. And see that green 4 right there? So I have 4 minus. Now, be very careful. A common mistake is a lot of times students will write minus x plus 4, just like this. And this is why the problem will end up being wrong. The parentheses are a hint. This is really 4 minus the quantity x plus 4. This negative sign has to be distributed throughout the parentheses. So if you imagine, I guess distributing a negative 1, what will really happen is we will have minus x minus 4. So I'm just going to make that modification. All right, so feel free to do that in your head, but don't forget to distribute that minus sign. This plus 4 has to become a minus 4. So let's combine like terms and see what happens. Okay, so this will be the same thing as the limit as x approaches 0 of, we have 4 and then minus 4. These 4s are going to cancel each other out. Don't forget about that negative sign right there. So in the numerator we have negative x. And the denominator is unchanged at the moment. So we have 4x times x plus 4. Notice that we have a common factor in the numerator and the denominator that we can cancel out without changing the limit. So if we cancel these out, we are going to get the limit as x approaches 0 of, Well, these are gone. So I have to have something up here, so I'm going to put a 1. And then in the denominator, I will have 4 times x plus 4. Now we can do direct substitution. So in fact, I'm just going to go ahead and write direct sub. And as soon as you do your direct substitution, that's when you can stop writing the limit as x approaches 0. So I'm going to let x be 0. So really that means I'm just going to write nothing when I get there. So this will be negative 1 over 4 times 4, which is negative 1/16. And that is the limit.